Section 3 is really about the settlement boundary. Um, because of Section 1, we're familiar with land cover types and the changes that can occur as a refugee settlement is established. From satellite imagery, we've identified some building footprints that are then used usually in humanitarian context for population estimates. So now in this section, we're going to look at formally delineating the refugee settlement from its surroundings. And by doing so, we're really going to make a settlement boundary. That's the whole goal of this section 3. And I had mentioned that in section 2 as well. So in this case, having information on the refugee settlement boundaries is helpful for the extent and for confidently attributing land cover or land use changes to a specific refugee settlement. And there's a few sources that support that claim in the book, so I invite you to look at that as well. But in this section, as we're saying here, we're going to be using a lot of k-means. We're going to use a k-means unsupervised classifier for a classification to generate a settlement non-settlement map. And that's going to represent land that has been transformed by the refugee settlement's establishment or subsequent use. So the settlement boundary that we used in section 1 is one that was established by the UNHCR, and it represents a land within the formal boundary that potentially could be accessed or used by refugees. So we're going to make one on our own. And I'm saying this because it might have been confusing at first to see that we have a settlement boundary, but now we're really working on how do you create one. And so it's going to be a lot of binary classification, creating a random sample, using our NDVI values again, doing a k-means classification, produce a single contiguous settlement coverage by applying the spatial morphological operations of dilation and erosion. And this is again with the k-means output. We're going to convert the output, create a usable vector map of settlement and non-settlement polygons, and we're going to use those to create a single polygon that represents the settlement boundary. And that's going to be through intersecting k-means polygons. So let's get into it. First, we're going to be copy pasting from checkpoint C, and then copy pasting into our new script. Okay, so let's get started. We're going to start delineating refugee settlement boundaries. So I'm just going to close this. Okay, so I'm just going to close the charts here. So in section 1, the boundary we were working with, as I mentioned, is a settlement plan boundary established by the UNHCR. And so this represents this blue boundary here, represents the land within the formal boundary that potentially could be accessed or used by refugees. So in the end of this section, we'll be comparing the k-means boundary that we make and the UNHCR's settlement boundary that we were working with earlier. So to start, we'll start by making a binary classification that separates settlement from non-settlement. And to do that, we're going to create a random sample of 500 NDVI values from across the post-establishment composite. So again, we're using the post-median. And remember that the post-median composite was clipped to the 500-meter buffered extent of the UNHCR settlement boundary geometry, like we had done in, well, I'm not going to go up, but in section 1. And these sample sites should be dispersed inside and outside of the UNHCR boundaries geometry because we have a 500 meter buffer. So here's our 500 NDVI, the k-means sample, number of clusters is 2 because we're doing a binary classification. And then you're using the cluster function to seed the classifier using the land cover samples. So you're training your data. And then we're going to apply the k-means classifier. We only need 2 values output from the classifier, and we're going to set the maximum number of iterations to a low value of 5. And then the seed value is an arbitrary value of 21. And once you have these parameters, which you would have from copy pasting, we're going to apply the k-means classifier to the post-establishment composite, the post-median, sorry, and we're going to be able to view the coverage of settlement, which is going to be pixel value 1, and non-settlement, pixel value 0. And then we're going to visually compare the result with this blue UNHCR settlement boundary. I'm going to run this part. Now it's going to run what's on top, so it's going to be a bit long. So you've got your k-means samples. This is what we did here. So the 500 NDVI samples. And then you've got your k-means output, and that's going to be your classification. And so the resulting k-means classification here, it looks pretty promising for separating settlement from non-settlement pixels. You can see kind of the boundary. So in black's going to be our one. However, there's a lot of gaps in the settlement coverage as well as isolated settlement patches and pixels because you can see here we get an idea of what's happening, but there's a lot of patches of black and white, which will determine what's there, what's not, or in our classification. So because we have some gaps, we want to produce a single contiguous settlement coverage. And to do that, we're going to apply spatial morphological operations such as dilation and erosions on the k-means output. So we're going to call it k-means cleaned. And first, dilation, for example, is incrementally expanding the boundary of a raster dataset and filling gaps and connecting patches all along the way. And erosion works with the outermost pixels, removing the surplus pixels that were added during the dilation step, but still maintaining the filled in gaps. So dilation is going to fill the gaps, connect the patches, but erosion is going to remove what was extra, what was added on extra by dilation and work with the outermost pixels, but it's going to keep the filled gaps. So by doing those two, we should have somewhat of a single contiguous settlement coverage. So that's what's happening here. We're doing the k-means clean. So we're going to start with dilation, and then we'll do erosion. So you'll do focal max, focal min. Focal max works as a dilation because it outputs the maximum value detected within the kernel, and that'll always be a settlement pixel because the settlement pixel value of 1 is always greater than the non-settlement pixel value of 0. And we just need to do some fine tuning on the boundary of the settlement coverage so we can use a kernel with a small radius of 3. And then we're going to convert the output of the dilation and erosion to a polygon feature collection where each contiguous patch of pixels becomes its own polygon. So if you look here, you've got the k-means output before, which is what we were seeing with the settlement boundary. And then you have the right, which is after dilation and erosion. You can see that there's gaps that are it's cleaning it up where it's more contiguous and you have more of an idea of what's happening. So that's kind of what we're working with. And as I keep showing, you have the boundary here. If you want to show that, you're going to have to map it out again because I tried to put it as a layer and it didn't work. So you have to map the outline, and this is just using the code from the previous section. It's always the same thing. And then we'll get the k-means output before and after dilation, erosion, and then we're going to do an intersection because the goal is to compare. So I'm just going to, before we do that, we're going to run. So basically, we've created our k-means settlement boundary, and now we're going to compare it after with the UNHCR settlement boundary because we want to see if the k-means boundary is accurately separating the settlement from its surroundings, for example. So by using the UNHCR boundary, it's giving us an idea of how our classification is doing. So this is what we had originally. Got the k-means output, and then you've got the k-means clean. So notice how it changes into a more contiguous coverage. And this is because we're filling in the gaps, we're cleaning up using dilation and erosion. And dilation is again filling the gaps, but also connecting patches. And erosion is working with the outermost pixels, just removing anything that's surplus that was added during dilation and maintaining the filled in gaps. And so remember, then we converted the output of dilation and erosion to a polygon feature collection. So we have a feature collection that represents each contiguous patch of pixels as its own polygon. And so from this, by creating it into a polygon, or polygons. So we have our polygons. We've created a vector map of settlement and non-settlement polygons that we can use. But what we want is a single polygon that represents the settlement boundary. So to filter these polygons, the creator of the code filters these polygons to a single polygon representing the refugee settlements boundary by using a simple logic rule and selecting the polygon that has the largest overlap, so intersected area with the UNHCR boundary. And this is what's happening here. So you have the k-means intersect, that we're creating, and it's intersecting k-means polygons with the UNHCR settlement boundary and returning intersection area as a future property. And this is going to give us a single polygon that represents the settlement boundary that we can then work with and overlap and compare. So what we're saying here is this here is most likely going to be the polygon that comes out because it's the largest vector polygon that you notice already from observations that is going to intersect with our boundary, right? So you should expect this to come out. Um, and what you're doing is just the creator created this, the creator of the code is basically using this function with boundary esect and doing the boundary and returning a feature property. So the creator of the code is just using this function with the k-means clean polygon we just did to make this intersection. And basically with the function, it's setting its variable, returning the variable, using the intersection function to create this k-means intersect variable. And with this variable created, you sort to select the polygon with the largest overlap with the UNHCR settlement boundary by using the variable you created, sorting it by getting the first. So that's going to bring the largest. And that means that when you print out k-means boundary right here, it's going to give you a new polygon, a single polygon this time that is technically giving you the largest overlap with the UNHCR settlement boundary. Once that's printed, so let's run it. We get a k-means settlement boundary that's going to be black, like this. And it's going to be overlaid by the UNHCR settlement boundary blue, Pegarinia, which we've been working with this whole time. And we'll wait for that to show up. But this is what I mentioned at the beginning of section 3. We're doing a comparison between settlement boundaries, and we're interested mainly in the one by UNHCR. So with the data we have, we're trying to work with this main boundary and compare our results to see, again, as I mentioned, if the k-means boundary accurately separates the settlement from its surrounding, for example. And then after that, we can move on to section 4, where we're going to work with different data sets used to estimate the geographic distribution of human populations. And that's primarily based on remote sensing detection of buildings that we looked at in section 2, if you remember. So this section is kind of a middle ground where working with the main boundary, you're doing a classification and using something that you know with something that you've created for a comparison tool. And there's questions in the book, which again you can go to and learn more about to understand the code or see if you understand the code and how to work with it. So let's see what it gives us. So now you've got your k-means settlement boundary. We're going to keep the Pegarinia. So as I mentioned, remember if you have the clean polygon, you see what happens here is you've got the k-means clean polygon and the k-means cleaned. So the k-means clean polygon is what we had created earlier with our polygons. And you remove this k-means cleaned, and then we intersected to get the largest overlap with the UNHCR, which, as I mentioned, you can tell that it's going to be this here because that's the biggest one we're seeing intersecting. And so that's what shows up and kind of colors it in. And then it's up to you to determine how accurate it's representing or separating the settlement from its surroundings. You can see that there's some gaps missing and there's some overlap here where the boundary is. So some things to think about. And now we're going to go into section 4 and work with human population data with our boundary.